Okay, so we discussed various factors that affect the strengths of acid. But now I'd like to show you in this video how to apply all this knowledge to problem solving. Because what I observe a lot of times with my students, they come to me and they say, I read the book, I memorized all the facts, I still can't do the problems. So I will show you how to approach this. But before we do this, I'd like to summarize what we have been talking about. We discussed different factors that affect the stability of the conjugate base. We talked about charge, right? Charged species versus neutral species. We talked about the atom that is carrying the negative charge and which atom can be more accommodating for negative charge. We talked about the effect of resonance, inductive effect, and hybridization. But what happens when you have to compare two conjugate bases and there are all these different factors at play? Which one wins? So the order in which I listed these factors here is the order of importance, right? So atom wins over resonance, resonance wins over inductive effect wins over hybridization. So let me show you how this would be applied to a specific problem. So this is a very typical problem that you can see on the exam. Rank the following in the order of increasing acidity, and you're given a list of compounds. So the first thing that you need to do is to write out the respective conjugate bases. Remember that the most stable conjugate base will correspond to the strongest acid. So let's see what we have here. So for HF, we have F minus. For ammonia, we would have NH2 minus. And for methanol, this would be a methoxy ion. And this is acetic acid. So here I actually will draw it out and you'll see in a minute why. Some of you probably guessed already. And the hydronium ion, its corresponding conjugate base is just water. Okay, so now let's see how we can rank these in the order of decreasing stability. So let's find the most stable one. So if we go back to our list, on the top of that list is charge. So in other words, if you're comparing charged species versus neutral species, the neutral species wins. And it doesn't matter what atoms are involved, right? So in this case, water is the clear winner here. So water is the most stable. So that gets the first prize because it's neutral, right? Okay, so now among the remaining species, we have the following atoms carrying negative charge: fluorine, nitrogen, oxygen, and oxygen. So the rule tells us that the most electronegative atom wins, right? So the second place goes to fluorine minus, right? Fluorine is the most electronegative atom. Therefore, among all of these, it's best suited to accommodate negative charge. So now we have nitrogen versus oxygen. So we know that oxygen is going to win. But look at these two anions. We have a methoxy anion and acetate anion. And we know that acetate anion can have a resonance form, right? Its resonance stabilize. So we can draw the following resonance, right? It would be CH3, CO minus, and then the other oxygen has a double bond. So acetate wins. So we have acetate. I will just write it as CO2 minus. And then let's move the screen a little bit here. The fourth place goes to methoxy, right? It's off the podium, but still an honorable fourth place. Okay, and then the last, the least stable of all is NH2 minus. Okay? All right, so just to remind you, this is most stable conjugate base, right? And NH2 minus is least stable conjugate base. So based on this ranking, we can then find the weakest acid, right? The weakest acid would be NH3, right? So now the answer to this problem is the following. Remember, we need to rank these compounds in increasing acidity. So we're starting with the weakest acid. So this would be NH3, right? Followed by methanol, followed by acetic acid, followed by hydrogen fluoride. And you can always check your work by looking up pKa's. The pKa of ammonia is 36, of methanol is about 16, acetic acid is about 5, or actually it's 4.7, and hydrogen fluoride is about 4. So the pKa is decreasing that way, and that means acidity is increasing that way. So now let's look at another type of problem that you will be seeing on the exam. You're given a structure and you're asked which proton is more acidic. Is it red one or is it green one? So let's again draw the corresponding conjugate bases. So if we remove the red proton, then we will get the following conjugate base. So there will be a negative charge on nitrogen, and everything else remains the same. And if we remove the green proton, then the conjugate base would look like this. There is your negative charge. So now we have a choice. Do we want our negative charge on nitrogen, or do we want our negative charge on carbon that is resonance stabilized, right? We can draw a resonance for this anion. Let me draw it a little bit lower. It would look like this, right? This is called allyl anion, and we can draw resonance for it. So it would look like this. Now, let's look at our list of factors. Atom wins over resonance. Therefore, this would be the more stable conjugate base. Red proton is more acidic, right? More acidic.